Okay, I'm going to work out the practice test for Chapter 5, and I'm going to work it out page by page. So in the when you find the on Schoology or wherever it's going to be posted, each page will be a separate file, so you can focus in on the ones that you need. So for this one, we've got a negative 128, and we're looking for the fifth root of that. So what we're going to do is we are going to break this negative 128 up, so it's negative the fifth root. Now my 32 equal to 32, so if I can break that up into 32 times 4, then what's going to happen is the 32 is going to come out as a 2. So what I'm going to have is that negative still there, a negative 2 times the fifth root of 4. Moving to the next one. What we have is we have two fifth roots. Now you can combine those under the same root, but if I take and combine those under the same root, I would have 5, the fifth root of a negative 5 over 8. That's not going to help me any, so I'm going to split them up. And that's going to be the fifth root, or 5 times the fifth root of a negative 5, over 3 times the fifth root of 8. And what I'm going to need to do is I need to get this 8 to be a perfect fifth root. So let's go ahead and 8 right now, that would be 2 times 2 times 2, that would be 2 cubed. So what I need to do is I need to get that to be a 2 to the fifth power. So what I really want to have is I want to have 3 times the fifth root of 2 to the fifth. So to get that to become 2 to the fifth, I'm going to have to multiply by the fifth root of 2 squared, because then the 2 cubed and the 2 squared can combine and be 2 to the fifth underneath the radical sign. Of course, I can't just multiply the denominator that way. I have to do the same thing to the numerator. So I'm going to multiply the numerator by the fifth root of 2 squared. So these are both fifth roots. They're going to combine and be 2 to the fifth, and what I'll have in the numerator is the fifth root. 5 times the fifth root of a negative 5 times 2 would be a negative 10. Okay, we already said that 2 to the fifth, and then take the fifth root of that, that's going to be a 2 coming out. So the 2 multiplied times the 3. So what I'm going to have is I'm going to have 6 in the bottom, and on the top I'm going to have 5 times the fifth root of a negative 10. Actually, there's a mistake there, if you see it. A negative 5 times 2 squared, that's a negative 5 times 4. So this will be a negative 20. And so this will be a negative 20. Now this answer isn't wrong, but what you're going to see is a lot of times you're going to want to take that negative out. Now that's a fifth root. So another way to write that would be the fifth root of a negative 1 times 20 all over 6. And then we could take the fifth root of a negative 1 is just a negative 1, which would be a negative on that 5. So another way that we could write this, and which would probably be most the way that's most shown in books, would be that we could write this as also a negative 5 times the fifth root of 20 all over 6. So both of these answers are the same. Let's go to the next one. Okay, so what I'm going to do is combine these, and if they have the same radical, this is a cube root and a cube root, so I can combine those under the same cube root. So I'm going to have a negative 6 times 3, that's a negative 18. And I'm going to have a negative 20 times 150. And a couple things here is what we saw before is, let's kind of break this up into some factors that I know can easily see what can combine. So let's do this. So we're going to have a negative 18 times the cube root, and let's say that 20, that's going to be 4 times 5, so 2 squared times 5. And then we have 150, and that's going to be 5 times 5, so that's 25 times 6, so I could say that's 5 squared, and 6 is 3 times 2. So I've got 25 times 6, and I've got 4 times 5, so those are right. And then I'm also going to put times a negative 1 for that negative, and let's see what we can get out of there. So rewriting that, I've got a 2 cubed times 2 squared times 2, well that's a 2 cubed. And so I've taken care of those two. I've got a 5 squared times 5, that's 5 cubed. And now I have times 3. And the negative 1 can come out as a negative, so I have a negative 1 here. So what I'm going to have is I'm going to have a 2 coming out. I'm going to have a 5 coming out. This 3 stays, and I'm going to have a negative coming out because it's a negative 1. And that's going to be 2 times 5 times, now I have a negative coming out, and that's a negative 18, so that'd be a positive 18. And what would be left underneath there would be the cube root of 3. That would be 18 times 10, that's 180, times the cube root of 3. Let's move over to the next one. Now I'm subtracting, so that's not a multiplication, that's a subtraction sign. So the only way I can subtract those is if what's underneath the radical is the same. They're both fourth roots. So I need to get this, somehow I need to get this to look like it's a fourth root of 4. And what we can do there is rewrite this as a negative 3 times the fourth root of 16 times 3, 16 times 4. Minus 3 times the fourth root of 4. Well, the fourth root of 16 is 2, so this is coming out as a 2. That's going to give me a negative 6 times the fourth root of 4, minus 3 times the fourth root of 4. So I have a negative 6 and a negative 3. That's going to be equal to a negative 9 times the fourth root of 4. Okay, let's look at the next one. So I have a fourth root. So let's go ahead and break these up into perfect powers of 4. So I would have 3 in the fourth root. Now 48, that's 16 times 3. 16 is 2 to the fourth power. I have h to the 6th, so let's say that's h to the 4th times h squared. I have j to the 8th, and I have a k. Okay, so let's see what's going to come out of there. The fourth root of 16 is 2, so 2's coming out. 3 stays under, h to the 4th comes out. Now, because I can't have a negative on an even root, this h is going to have to come out as an h, and since the power is 1 on that, I'm going to have to put that underneath absolute values. This h squared stays under. Now j to the 8th would come out as j squared. The fact that it's squared, if j was negative, would make that positive, so I don't have to use absolute values, and the k is going to stay under. So I've got 3 times 2, that's a 6, times the absolute value of h times j squared, and the 3 would stay under, h squared stays under, and k stays under. Okay, the next one. Now it's a cube root, so I don't have to worry about any absolute values. So I have a negative 4. 32, that's 8 times 4, and 8 is a perfect cube of 2, so that would be 2 cubed times 4. I've got p to the 4th, so that's p cubed times p. I've got q squared. That's not going to be able to be made any simpler to come out, so I'm ready to take some numbers out. The 2 cubed comes out as 2. The p cubed comes out as a p. So I have the 2 times a negative 4, that's a negative 8. And then I have a p also. And what's left under is the 4. Wait, this is a q. Somehow I left some of that stuff out, so I've got a q squared. Wait a second. The q squared stays under and the r stays under. So this p stays under, so let's go back and forth. So the 2 cubed comes out, the 4 stays under, the p cubed comes out. When I split the p to the 4th up, there's that p, that stays under. Q squared stays under, and r stays under. Okay, let's move to the next one. First thing to do is to distribute this negative 3 halves into the parentheses. So I'll have v to the negative 3 halves, u, negative 2 times a negative 3 halves. That would be a positive 6 over 2, right? So that would be positive 6 over 2, which would be 3. Then I have v and u to the 4/3. So what's going to happen next is the like bases will combine. So I'm going to have the v with the negative 3 halves and v to the 1. Those will add, and I get v to the negative 1/2. I get u to the 3 plus 4/3. So let's go ahead and change the 3 to 9/3 so that I can add those. So 9/3 plus 4/3. So that's going to give me u to the 9 plus 4 is 13 over 3, 13/3, all over v to the 1/2. Okay, now I can't have this 1/2 in the denominator because that's really the square root of 2, so I'm going to have to do something. And what I want is that to become v to the 1st power. So what I'm going to have to do is I'm going to have to multiply by something that's going to make this 1/2 becomes 1. Well, that's going to be another v to the 1/2 because 1/2 plus 1/2 is 1. So if I do that to the denominator, I have to do that to the numerator. So what I'm going to end up with is v to the 1/2 times v to the 1/2. That's v to the 1st. And my numerator will be u to the 13/3 v to the 1/2. Of course, that can be written without the 1 on the v, so and that would be my answer. Let's do the next one. So on the numerator, I'm going to go ahead and add all the exponents. I have 2 minus 1/2 plus 1, so that would be 3 minus 1/2, that would be 2.5, that would be 5/2, right? 2 minus 1/2, that's 1.5 plus 1, that's 2/2. So I've got x to the 5/2. And my denominator, let's go ahead and distribute that negative 1 in. So that's x to the negative 1/3. So now then, they both have the same base of x. So we're going to take the 5/2 exponent minus the 1/3. So that's going to be x to the 5/2 minus 1/3. They need a common denominator. That'll be 6. So I've got 15/6 minus 2/3, 2/6. So I'm going to get x oops, it's another mistake here. Okay, let's try this again. Okay, so this is going to be 5 halves minus a negative 1/3. So that's going to be x to the 5 halves plus 1/3. So now let's give them a common denominator. That's x to the 15, 6, and then 1/3 would be changed to 2/6. That's going to give me x to the 17/6. Next one, I'm going to have 3 to the 3 halves, n to the 3 halves. Now let's combine the terms on the denominator. So I've got 2 times 3, well that's 6. And I've got n, and this is n to the first. That's going to add to negative 3 halves. So I have 2 over 2 minus 3 halves. That's going to be to a negative 1/2. Okay, so the 3 and the 6, that's going to give me 3 divides into 6 twice. That gives me a 2 as a denominator. And this is going to be the n, and I've got 3 halves minus 1/2, so that would be 3 halves plus 1/2 because it's minus a negative. That's going to be n to the 4 halves all over 2, which is n squared all over 2. Next one. Okay, so let's go ahead and distribute the 5/4 in, so that's going to be a multiplication. So that's going to be x to the 20/12. 4 times 5 is 20. 3 times 4 is 12. Now the negative 1, that'd be y to the negative 5/4. And my denominator would have a z, x to the 5/4, y to the 7/4. Okay, let's do some combination from numerator to denominator. So I have 20/12 and 5/4. So if I would change this to a denominator of 12, you could see that that would be 15/4. So that's smaller. So I'm going to take the 20/12 minus the 5/4. So for the x, that's going to be x. I've got 20/12 minus 5/4. We already said that is 15/12. Now let's go to the y's. And what I have is I have a y that has a 7/4. Up here, that's a negative, so this is definitely more positive. So I'm going to have y to the 7/4 minus a negative 5/4, so that'd be plus 5/4. And then I've got the z. Okay, so now I'm going to have in the top, I'm going to have x to the 15 Actually, I just noticed I left something off this. You see this term here? I forgot about that completely. So let's go ahead and add that in. That would be times x to the negative 1/4. That's going to have to add. So this negative 1/4 is going to add to the 20 over 12. So let's go ahead and fix that. Okay, so we're going to have x to the 20/12. And we have to subtract 1/4, so we're going to change that. That's going to be minus 3/12. And then we have the y to the 5/4 still, negative 5/4, all over z, x to the 5/4, y to the 7/4. So I've got x to the 17/12, y to the negative 5/4, all over x to the 5/4, y to the 7/4, and z. Okay, so let's take, and we're going to take the numerator, the x 17/12 minus the 5/4, which you're going to change to a denominator of 12, so that would be x to the 17/12 minus 15/12. That's going to be all over y, and it's going to be 7/4 minus this negative 5/4, so that's plus 5/4, and then we have z. So for my x's, I'm going to have x to the 2/12 all over y to the 11/4, 12/4. 7 plus 5 is 12, so 12/4. Times z. So that's going to be x, 2/12 is 1/6. The denominator, 12/4 is 3, and z. That was kind of painful. End of the page.